For most of human history, scientists believed light traveled instantly. That assumption held for roughly 2,000 years. But today, we know that the speed of light is exactly 299,792,458 meters per second. But how can we be so sure about this? Is it actually accurate? Could it be argued that no one has never actually measured the speed of light? The belief that light was instant was not a guess from ignorant people. Aristotle said so, Descartes said so, Kepler said so. These were the sharpest minds on Earth, and they all agreed. Light leaves a source and arrives everywhere at the same moment. No delay, no travel time. It simply exists. In 1676, Danish astronomer Ole Rømer was doing something that sounds almost boring. He was tracking the orbit of Io, one of Jupiter's largest moons. He was timing its eclipses, watching it disappear behind Jupiter and reappear again. Routine astronomical bookkeeping. Except the math kept coming out wrong. When Earth was moving toward Jupiter in its orbit, Io's eclipses came slightly early. When Earth was moving away, they came slightly late. The difference was about 22 minutes across the full diameter of Earth's orbit. Rømer realized the delay was not an error. It was the time it took light to cross that extra distance. Even though Rømer was not trying to measure the speed of light, actually didn't even know that was possible, the universe handed him the answer anyway. He proved for the first time in history that light wasn't instant. It had a speed. Shortly after, using Rømer's data, physicist Christian Huygens did the math. He calculated light traveled at roughly 220,000 kilometers per second. He was off by about 26%, but that didn't matter. The foundation of physics had been permanently rewritten. 50 years later, English astronomer James Bradley came closer. He noticed something strange about starlight. Stars appeared to shift their positions slightly depending on the direction Earth was moving. Not because the stars were moving, but because Earth was. He called it stellar aberration. It is the same reason raindrops seem to fall at an angle when you run through them. He used this effect to calculate the speed of light at 301,000 kilometers per second. Remarkably close. But both of these measurements depended on astronomical distances that were not perfectly known. The error bars were large. The scientific community accepted the results, but precision was still missing. Then came Leon Foucault in 1862. He brought the measurement down to Earth. Literally. Foucault built a device using a spinning mirror and a beam of light. He bounced light off the rotating mirror, sent it down a long room to a second fixed mirror, and measured how far the spinning mirror had rotated by the time the light came back. The tiny angular shift revealed the travel time. His result was 298,000 kilometers per second. He did this in a laboratory, not with stars, not with planetary orbits, with a spinning mirror and geometry. He took a cosmic speed limit and trapped it on a tabletop. Albert Michelson refined the experiment further in the 1880s and again in the 1920s. His 1926 measurement, conducted across a 35-kilometer path between two California mountain peaks, gave a result of 299,796 kilometers per second. Nearly exact. But here is the final twist. The measurement that ended the race wasn't really a measurement at all. It was a surrender. By the 1970s, scientists were using lasers and atomic clocks to measure light with terrifying precision. But they hit a wall. The numbers stopped getting cleaner. At the time, a meter was defined by a physical platinum iridium bar sitting in a vault in Paris. But at the quantum level, physical objects change. Atoms vibrate. Metals slightly expand and contract. To a laser beam, that metal bar was a fuzzy, shifting target. We hit a physical limit of precision. So in 1983, the international scientific community stopped trying to measure the speed of light. Instead, they locked it in. They declared that the speed of light in a vacuum is exactly 299,792,458 meters per second. They flipped the issue upside down. Instead of using a meter stick to measure light, they used light to define the meter stick. Today, a meter is officially defined as the exact distance light travels in 1,299,792,458th of a second. So is this the real final speed? Kind of, yes. But one thing is sure, it will most likely never change. Even if we invent unimaginably better technology 1,000 years from now and take an even closer look, the speed of light will not shift by a single fraction. Instead, the length of a meter